All right, welcome. Thank you all for coming here this morning. If you don't know me, my name is Dr. Nick Deardorff. I'm the chairperson of the Department of Geography, Geology, Environment, and Planning. Did I say that right? Okay. And I'd like to welcome you to the 48th Annual Geoscience Day. This is the 48th Annual Geoscience Day, but it's the first since we've merged departments. Geoscience merged with Geography and Regional Planning. So it's extra special for that particular case because we have geographers and regional planners presenting here today too. We have, I think, 1 or 2 oral presentations and some posters during our coffee session here in a little bit, along with our geology majors that will be presenting. So that, and I'm seeing actual faces at Geoscience Day, and the last 2 years have been virtual. So I'm particularly excited just that we're here in person. So thank you all for coming, family, friends, students, faculty, alums. We're really excited to have you all here. We're very excited to honor our students and the presentations that they're about to give and the hard work that they've done over the course of this semester, year, last few years. This culminating event is really special to our department, especially to the faculty who worked very hard to help these students along, not nearly as hard as the students have, but I think we need to give a little bit of recognition to the faculty who have helped guide these projects along. The point of today is to honor the students and the hard work you have all done, but I think we need to honor the faculty as well. And in particular, Dr. Karen Rose, who has organized this event, and Dr. Farnsworth, who has fought very hard to get this streaming live right now. Hopefully they can hear me.
For me, I'm the only one watching.
Honestly, that's all that matters. So anyway, so thank you very much for all of your hard work and dedication. I guess that's all I had to say. Dr. Masilela is the assistant chair of our department. Did you want to say a few words?
Yes, I have to.
I'm not twisting your arm.
Oh, yeah, right. Okay, all right, good morning. As Dr. Deardorff just pointed out, I am Professor Masilela and the assistant chair of our expanded tent. And I gladly echo these sentiments to thank you, our students, for participating in Geoscience Day, and in particular, our faculty who have showed up to support you, alumni who are here as well. And to our Geography Regional Planning Program students, we especially welcome you to this tradition that has been going on for almost 5 decades. 40th, that's really impressive. Then I'm hoping that next year, this time, many of your colleagues in regional planning and geography will be participating. I know some of them had to go to Pittsburgh for a field course, so that's why they are not here. I see Chad here. Excellent, thank you. And last but not least, I really also want to echo and thank Professor Karen Secon and Farnsworth back there for putting this event together. And it's something that is greatly appreciated, particularly at the end of this semester. Things get really kind of patched up. And again, thank you. And with that, let the show begin. Thank you.
Thank you.
I'll be your master of ceremonies, which means I'll be switching the PowerPoints around and introducing our speakers. And we're very happy to start our morning session, which is environmental. Let me see if I can make this work. There we go. Are we good? We're on the right slide? Yes. Has a focus on environmental remediation of, I think I'm on the wrong slide, Chad. I apologize.
I'll give you a minute to look at the abstract. Okay, so where does the blight issue come from? And in the case of post-industrial cities, it is a supply and demand problem where you have a collapse of heavy industry following World War II, getting into the latter half of the 20th century, and you have mass exodus from some of these cities. Deindustrialization of small mining and steel producing cities in the Midwest and Mid-Atlantic is really what I'm going to be focusing on today with Johnstown as the case study. And Rust Belt cities have lost an average of 1/4 of their total peak population. Those populations have peaked at various years, but mainly focusing on years following 1950 through the 1980s. The abandonment of commercial, residential, and industrial structures is rampant in communities that are facing this problem. For the purposes of my research, I'm going to be focusing solely on residential. Small Rust Belt cities are particularly struggling to adapt. When you think about case studies like Pittsburgh and Detroit, these are cities that are seen as either success stories or success stories in the making. For some of these smaller communities, they don't have the advantages of these larger cities, and adapting to this new post-industrial reality is much more challenging. So introducing the case study, Johnstown, 40 minutes down the road, as of March 2020, has reported 138 blighted structures in need of, or has demolished 138 structures. And there are 871 vacant properties. Most of these properties are considered blighted, which accounts for almost 8% of the city's total over 12,000 housing stock. And currently the city has no land bank when this was written. However, as of March, the city has passed legislation to enact their land bank. So that is very good news. And the graphs you see here are showing the declining occupancy rate as opposed to buildings available on the market. And this is showing the vacancies increasing with properties that are available for rent or for sale, decreasing or nearly flatline. So basically what this is telling you is there are a lot of buildings that are empty, but are not on the market and not being rented. And that leads directly to blight. And what does the literature say about land bank programs in particular? How do land bank programs impact residential and real estate values in small Rust Belt cities? And declining in Rust Belt cities is a blight problem, where heavy manufacturing declines through the latter part of the 20th century, as already stated. And like I said, Pittsburgh and Detroit are seeing similar losses. They've seen about 40% total population loss since their peak, and different challenges for large and small Rust Belt cities. Blight has a really profound impact on property values. Blight and abandonment leads to further blight and abandonment. And demolition alone is not going to get us to a solution to this problem. A lot of small cities see the problem, and it's such a visible problem that the local leadership, the local politicians are pushed to act. And a lot of times they're removing structures that are contributing to the urban fabric of what makes these places worth caring about. And we've seen in Johnstown buildings that are demolished just simply due to lack of demand. And that strategy is causing more harm than good. And blight has a profound impact on properties in the vicinity. If you're in a neighborhood with a blighted structure, it's going to have impacts on your personal property values, regardless of the condition of your own home. And the primary goal of land bank, I've talked a lot about this program without defining it, is to interrupt the blight cycle of abandonment. And in Pennsylvania, this problem is particularly rampant because of the tax sale process of blighted and abandoned structures getting put onto the county's tax sale process, where anyone can show up, bid on these properties and get them for pennies on the dollar. And a lot of times what happens is they have no intention of ever restoring or putting them back into occupancy. They simply use them to leverage more value out of the property. And in 5 years, we see the same properties back on the tax sale list again. And that's what this graphic is showing. It's the blight and abandonment cycle where these buildings get stuck in this process with no hope of ever generating tax income. And that's really one of the main drivers of a land bank program, is to get these buildings back into taxation. There's no data specifically supporting how much Johnstown is being hurt by this cycle, but Dayton, Ohio, it was estimated that they lost $7.8 million in revenue simply on tax delinquent property values, or tax delinquent properties alone in 2006. That would be a profound impact to the budget of a city like Johnstown. And to define what I'm actually talking about when I talk about blight, it is a very difficult thing to define. It really comes down to code violations is a big one. So if you're looking how to quantify how many structures are blighted in a community, just because it's abandoned doesn't mean it's blighted. And just because it's occupied doesn't mean it's not blighted. So the codes department is really the biggest advocate for determining what houses are blighted. But a lot of the times it comes down to, are the utilities on? Does the property actually have a roof, windows? Has the landscaping been maintained? All of these things contribute to what's considered blight, but there is no defined definition. So the results, quantitative is very difficult just because of when you're talking about residential real estate values, it's a very difficult thing to measure, especially when you're trying to do a comparison, because it is impacted by so many other factors. So while it would be beneficial to say that land bank has a direct impact on residential real estate values, lack the ability to quantify that just because of the fact that it's such a difficult metric. Real estate values are impacted by too many other factors, difficult to compare cities. A prime example would be if Johnstown introduced a land bank and saw increasing property values, but they also saw the introduction of a major employer. Was it the land bank or was it the employer? So even looking between cities, it's a difficult thing to quantify. And another problem I ran into is land banking in Pennsylvania is fairly new. As of 2018, which is the course that Johnstown took, the redevelopment authority is authorized by the state to become the land bank authority. And before that wasn't possible. So that allows a city with limited resources to designate the redevelopment authority as the land bank rather than setting up an entirely independent board. And more research is needed to determine the effectiveness of land bank programs and their impact on blight. The conclusion, Johnstown should, and thankfully they have, enacted land bank legislation. Demolition is potentially causing the problem to become worse before it becomes better. You see vast swaths of the city, even in the downtown core, that have been completely demolished with one or two houses left standing, and that has a profound impact on the real estate values of those properties, making it even more difficult for the people that are trying to have the means to restore these properties. They don't have the value in the house to do it, which is causing more blight problems. And especially in Johnstown, the housing stock is significantly older than the state as a whole. You're looking at an average house year built in the 1930s. And land bank can lead to increased revenue from properties. We've seen this in other cities. And private investment can't do this alone. That's one of the problems, thinking back to that graphic of the blight cycle. A lot of times the private market isn't going to be able to step in and get these properties back into taxation. So the land bank acquires them and is able to get them into the hands of somebody that's going to actually pay the taxes. And be aware of the forces of gentrification. We're a long way off from that in Johnstown, but as properties are reinvested, especially in traditional post-industrial neighborhoods, we've seen this in cities in the Northeast, Boston, New York, Brooklyn being the primary example, where you begin to become a victim of your own success and price out the people that have made it their home for generations. And that is definitely a downside to reinvesting in communities when it gets out of control. Resources are very scarce, and this is across the board with land banking programs. Proceed with caution. They are supposed to be self-funding. So every time the land bank acquires a property and sells it again, that revenue is going to buy and maintain more properties. But that has to get started at some point. Luckily for the city of Johnstown, they have a little bit of seed money to start acquiring some of these properties, but that's not something that should be the primary source of funding for these land banks. And further study is absolutely needed to monitoring these programs and determining what the impacts actually are. And land bank can be a bridge to a future for private investment, where anyone interested in acquiring some of these properties, instead of going through the completely Byzantine process of going to the courthouse, sitting in the courtroom for an entire day, waiting to bid, you have no idea what you're actually buying. You're not able to go into these buildings. And a lot of times there's a lot of legal liability that comes with buying these properties at tax sale. Land bank does away with all of that, where it's a straightforward process, almost like what you would do in the private market. And that's really one of the primary reasons why this program has such a positive impact on a city like Johnstown. And here are the works cited. And that concludes the presentation, pending any questions.
There's a million questions, but I'll probably bend a year later. But is the tax bank, I mean, is the land bank effectively, the title then goes to this shared vision? They're the title holders for these properties. It's a, who populates, who is the land bank?
Well, it depends a lot on how the municipality wants to set it up. In Johnstown's case, the city has its own land bank that's married to the redevelopment authority. The county has its own that's also married to the redevelopment authority, but they could have done county-wide, separate entities. There's a bunch of different ways to organize this, but as a land bank, they are authorized pre-negotiation with every taxable entity in the municipality. So they have to have an agreement, intergovernmental agreement with the school district and every other taxing entity. So for the JRA, it's the school district, the county, and the city all have to agree that when they go to the tax sale process to acquire these properties, that they're not going to receive the back taxes that they're owed on these properties, which is sometimes a bitter pill to swallow, but these properties are never going to become solvent. And then once that happens, the land bank gets a quiet title. So any liens, any judgments against the property go away, and it becomes so much easier to get these properties. Because I've seen it looking at the tax sale list, some of these properties have exponentially higher liabilities than their actual value. No private investor is ever going to touch them for that. And what the other nice thing that land bank allows a municipality to do is they don't have to compete in the bidding process. So if there's a property the land bank wanted to acquire, they simply go to the tax sale on the day and say, these are the properties we want. They immediately come off the list and they never go to the general auction.
All right, well, in the interest of time,
Thank you.
we'll let, hopefully Chad can stick around till coffee break and Dr. Lewis can bend his ear more then. All right, give me a minute because Dr. Farnsworth has said that I'm sharing the wrong screen. So I need to get up our next presentation and share the correct screen. So I'm going to stop the share. And then screen one is the one we want to share, I believe. Katie, tell me if that's not right. Okay, so our next few presentations for the rest of the morning are going to be students who just completed the GEOS 480 Senior Research Capstone course. And the first one of those is Caleb Cramer. He's going to be talking about Phase 1 Environmental Site Assessment of the Mount Union Railroad Museum.
Hi, everyone. I'm Caleb Cramer. I'm a senior here. And for my research project, I did a Phase 1 Environmental Site Assessment. Before I get into it, I want to define what a Phase 1 is and all the parts that come after that. So a Phase 1 is the process in which an individual or entity would request to determine if a particular portion of real property is subjected to recognized environmental conditions. Recognized environmental conditions would be contaminations such as petroleum and various chemicals. Why would this need to be done? It would need to be done to assess if a property that insurance companies, investors, or just somebody buying a property would need to see if there's any legacy contamination of it. This would assure those investors and insurance companies and just people buying the property that there is no contamination to the soil, groundwater that would devalue the property or limit the use of the property due to a cleanup that would need to happen. If deemed necessary, a phase 2 would then be done. Phase 2 is the field work. This is where you go out, you test the soil, you test the water, you get all those results to see if there's any contamination. Then after that, phase 3 would be done, which would then assess the extent of the contamination that was found in the phase 2. After that, phase 4 brings it all together, and then it would make up a cost-effective plan to clean up the area and do any remediation. My phase 1 was conducted at the Mountain Union Railroad Museum. For those of you who don't know, Mountain Union is a small town in Huntington County. It is where I am from. I picked this area because of Mountain Union's rich industrial history. A lot of different types of brickyards, tanneries, shoe factories, furniture factories, stuff like that. I chose the Railroad Museum in particular because of its close proximity to the railroads. That would indicate that there is different types of industries that would have been near the museum itself. Some ways that I did the phase 1 would be the use of Sanborn fire insurance maps. These maps were used from about the 1860s to 1970s. And with these maps, they can show us multiple areas of possible legacy contamination. Of the 3 areas that I investigated near my site, I was only able to find 2 Sanborn fire insurance maps. The other one, I had to go and do some internet searches, go to the local library to figure out what exactly that site was. For the first site that the Sanborn fire insurance map showed me was a old tannery existed north and upslope from the museum. This old tannery was shut down in the 1950s, and then it was later sold off to a local construction company for the storage of their materials and equipment. After that, I used previous research that was done that assessed the contamination of old tanneries of around the same time period. And what they showed is old tanneries had an abundance of chromium in the soil and water. On average, they found about 8 milligrams per cubic meter, which is way above the recommended. Like, recommended is anything below 200 nanograms per cubic meter. So that in itself would warrant a cleanup of that site. Why was chromium found in abundance at these old tannery sites? Well, that would be because chromium is used in the tanning process of leather. You get the hides, you soak it in a chromium bath, take it out, dry it, re-soak it, and then in those times they improperly dispose of it, usually just by dumping it out into the ground right at their property. The next site, this is the one that I could not find a Sanborn fire insurance map from, so I had to go to the local library and do some internet searches to figure out what exactly this property was. And what I found was that it was a brickyard that occupied much of the area west and south of the museum. It is this whole little outline right here. It was owned by Harbison Walker Refractories. It was one of the 3 Mountain Union brickyards. Later, it was shut down and then turned into a landfill / storage area for the other 2 brickyards. And it's now just an abandoned, gated off property owned by a local. Previous research of brickyards of around the same time period showed that they had chemicals such as TCE in the soil and water. In the water, on average, they found about 65 parts per quadrillion. And in the soil, they found on average anywhere from between 4 parts per billion to 6 parts per billion in the soil. Now, the recommended that it has to be below is 5 parts per billion. So anything above that, you would need to do some type of remediation or cleanup. TCE was used in the brick making process. It was used kind of as like a coating for the bricks. It's also used as like brake cleaners, stuff cleaning the rotors. Some health hazards associated with TCE is long-term exposure increases your risk of getting leukemia and liver cancer. Now, the museum itself was an old furniture factory owned by Dufresne Chair Co. And then later it was turned into the museum. Now, previous research of museums showed no contamination associated with them, but with the furniture factory, there is. Old furniture factories would have used chemicals such as PBDEs and PCBs in the furniture making process. The PBDEs were used as a flame retardant for the furniture. After the furniture was made, they would kind of like spray it and coat it with that to make sure that, it doesn't catch fire in the middle of your house. The PCBs were used as an adhesive to help keep the furniture together longer. Some health effects associated with PBDEs is cancer and neurodevelopmental defects. And then for PCBs would just be developmental defects of newborns, small children. With all of this in mind, from the Sanborn fire insurance maps and from previous research, it can be determined that contamination of the Railroad Museum site would be probable enough that a phase 2 investigation would be needed for any future construction or resale of the property, or if they would apply for grants. These are my citations, and I'd like to thank my research advisor, Dr. 𝐤𝐿, for guiding me through the process on how a phase 1 works and helping me put this together. Are there any questions?
Time for a couple of questions.
So TCE is a dense non-aqueous phase liquid when it's in its pre-product form.
Yeah.
To do a phase 2, because TCE is on the list, would that require something specific, a specific strategy for trying to, say you're good or you've got a problem?
Depending on how the underlying soil is, because of it being like a dense thing, if the soil is pretty compact, it will stay in the soil almost indefinitely. If the soil is pretty loose, then the risk of like moving that stuff, like drilling down, would kind of like help move it, and you don't really want to do that, so you'd have to be careful.
Questions before? So I have a question about along the same lines, those chromium numbers, you may have seen my eyebrows doing, those
Yeah.
are pretty darn high.
Yeah, they are.
Do you have any idea how one remediates that? How you can reduce that within that particular location? This is again, phase 2 and beyond, so you may not jump into it, but just curious.
Yeah, I didn't really jump into how the remediation of that would be done. Like, yeah, that would have to be assessed in the phase 3, in the phase 4.
Thank you.
All right, thanks you again. All right, so let me bring up our next speaker slides. We're going to continue on with our theme of evaluating environmental issues, but move to a different location now. We're going to a suburb of Pittsburgh, hopefully. There we go. All right. So our next speaker this morning is Daniel Cross, and he'll be talking to us about an environmental site assessment of Braddock Farms in Braddock, Pennsylvania. Daniel.
Thank you. Thank you, Dr. Spoon. Good morning. My name is Daniel Cross. I'm a student of geology here at Indiana University of Pennsylvania. And my big question was, can sustainable farming exist next to heavy industry? So I did a phase 1 environmental site assessment of Braddock Farms in Braddock, Pennsylvania. So this is just an overview map. Braddock is down the Monongahela from Pittsburgh, PA. And it's an old steel town. This is the area of the farm is in the blue square, and underneath the curvy blue line is the Edgar Thomson Steelworks, built by Andrew Carnegie in 1873. 2 years later, they started rolling steel, and they're still rolling steel there. And you can see it has close proximity to the farms, and it's maybe a 5-minute walk down the street. Phase 1 environmental site assessment is a method to determine if past use presents environmental concerns. So when you go to use the land for something else, for farming, we want to look to see what use exists there. And this is a picture, this is Braddock, and you can see a lot of it has fallen into ruin. And Sanborn fire insurance maps are an excellent resource for examining past use of land. So this is a broad overview of the town of Braddock in 1908. And the area of the farm is right here. This is the road that splits at 10th Avenue. And as we discussed before, you know, when buildings get demolished or raised, you don't know what used to be there. So you rely on these fire insurance maps. And they were done by the Sanborn Company, and they mapped things out in great detail so that when you sold somebody fire insurance, you would know what your liabilities were. For example, the pink buildings are brick framed, yellow is wood framed buildings. And on this one in 1895, they just have the names of the landowners. William Sherman, Kraft, Lloyd, owned the Hotel Lloyd, the 𝐼𝐴. By 1908, you can see it's been built up more. The Hotel Lloyd is still here. They've moved in some liquor stores. There's a cigar factory, barber, jewelry shop. So this part of Braddock was a main street, the high street of Braddock. Hotel Lloyd was the classy hotel you went to stay in if you were traveling through, if you had business with the steel companies and whatnot. And some of the good detail is, says here, damaged by fire, this little square. So you know this part of this building has already been damaged. And this says iron front. So I suppose this wholesale liquor store, I had nice big iron doors in front of them. And over time, additional businesses became established along Braddock Avenue. You can see more brick has come in, brick buildings, and they've established much more buildings using up the streets. However, with the collapse of the steel industry, the buildings on the current farm site were abandoned by the 1970s. This is the Hotel Lloyd in about 2004. So all those businesses, everything on the blocks just sat empty, and they were all torn down in 2004. So in 2007, John Fetterman, then mayor of Braddock, asked if Grow Pittsburgh would develop an urban farm in Pittsburgh. So Grow Pittsburgh is an organization in Pittsburgh that goes around and develops and maintains urban farms. And they said, yeah, we'll come build a farm. And you can see this is a picture from about 2015, when the farm was just getting up and running. And you can see the steel plant here. That's the Mon Valley Works, part of the Edgar Thompson Works. And the farming began in 2014. And again, you can see the close proximity to the steel plant. This is a little farm stand, so in the appropriate season, you can go and buy fresh produce, tomatoes, cucumbers, whatever they happen to be growing down there. The farm does regular soil sampling to measure pH. The farm maintains a pH of 6.5. They do this balancing with chemicals, phosphate and sulfur. In 2018, the soil was retested for lead. The US has no gardening standards for lead, but what they do have is a standard for lead in playgrounds. So that's what the farm uses, and that's 200 parts per million. We must be aware of air particulates that can dust the produce so close to heavy industry. So the mill's right there, and it's constantly blowing air pollutants out into the air, and they worry about whether or not any of that is getting into the farmland. So also in 2018, they got a grant to study and examine dust that falls onto the produce. And dust sampling of produce also tested for arsenic and chromium, among other pollutants. So make sure that your vegetables are clean and not absorbing things from the dust. Urban farming can be sustainable in the shadow of heavy industry. It requires toxin-free soil that must be monitored. And the farm does that on a yearly consistent basis to make sure that it's the pH levels are good and there's no toxins in the soil. And none of the usages seen in the sandboard maps would preclude farming. And for my acknowledgements, I'd like to thank Dr. 𝐚𝐴𝐿 to be my research advisor to help me down this path. I'd like to thank Dr. Kenneth Coles for helping me find the path. I'd like to thank Dr. Lewis for helping me with some questions and polish out my presentation. And I'd also like to thank Dr. Deardorff for helping me be here today to talk to you. Thank you for listening. Are there any questions? Yes, sir.
Are you aware that that part of Braddock is also the little old oil and gas field?
No.
Runs all the way from Edgar Thompson, works all the way up to buy Westinghouse House.
Now, I knew they wanted to frack on the land there, but they did not do that.
Yeah, they didn't do that because there were so many old oil and gas wells there that they were afraid to frack it.
Huh.
And there, there's actually a couple still existing wells there, one of which is right in that northeast corner where you showed the Braddock works. It's on
Okay.
one Braddock property.
Okay, I was not aware of that. Any other?
For Braddock Farms, what's the primary concern for contaminants? Do you think it's mostly prevailing wind and air contaminants, deposition of ash and things like that, or ground seepage of contaminants? What are they most worried about?
I think they're most worried about
Should they be?
the soil being contaminated from contaminants that come up through the soil.
Kind of pre-existing contaminants?
Yeah. Dr. Lewis?
I was just curious about monitoring like the dust that falls on the ground, or lands on the plants is one thing, but is there any, are there any standards for knowing how that actually might get into, you can wash your vegetables off,
Right.
but can any of these contaminants get sort of into the tissues of the plants that you were eating tomatoes, you're eating arsenic, which doesn't sound great.
I don't know. That's a good question. I was just informed they did the testing to see what was falling on the vegetables. They didn't do any like further research to see if it enters it through the skin or that kind of thing.
Okay.
Any other questions? Okay.
Thank you very much. Right. So we have one more speaker before coffee break to finish up our phase one session. That would take us from Pittsburgh north to a really interesting site that many of you may not even know exists. Just a second, Erik. Takes it a minute to come up. I think because we're logged into Zoom and everything else. There we go. Always comes up just as I get impatient and try to. All right, so our next speaker is Erik Reynolds, and he'll be talking to us about a former nuclear materials production facility north of Pittsburgh. Erik.
All right, so good morning, everyone. My name is Erik Reynolds. I'm a senior here at UP, and I'll be graduating next week with a bachelor's in geology. For my senior research project, I've done a phase one environmental site assessment of a former nuclear materials production facility. Like Caleb and Dan have explained before, phase one is a preliminary test that's done to see if there's any potential environmental risks on a particular site. So these can be used in a variety of different ways. It's a pretty broad sort of assessment. One way is, as Dan and Caleb have said, transfer of property agreements between banks, businesses. Business wants to buy a site, they want to make sure that it's environmentally sound and there aren't minimal risks involved. Another way would be prior to a cleanup event in which that there is contamination and you want to know what kind of possible contamination there could be on a site. One such site would be the former Babcock and Wilcox nuclear production plant and burial site, highlighted in yellow. It's a 44-acre site located between the towns of Vandergrift and Leechburg, which is about, if you're not familiar with the area, about 45 minutes southwest of here. Before we get into the phase one, a little bit about Babcock and Wilcox as a company. They began as a boiler manufacturing company, and they used the money earned from that and from several federal contracts to fund their way into the power industry, in which they were very successful, and they actually made a lot of money with that and became a giant in the industry, and they're still active today. They've shifted more towards green energy today. These days, so that's good on them. But during World War II, they shifted their focus toward nuclear materials manufacturing. Two examples of this would be they actually provided components to the Manhattan Project in the bottom left there, which was the atomic bombs. And in the top left, or the top right, they actually fabricated fuel for the world's first nuclear submarine, the USS Nautilus. And in the bottom right, they were actually the company that designed and constructed the nuclear reactor to the 3 Mile Island nuclear power plant that had an incident in the 70s. As far as the materials that they handled at the site, they mainly worked with uranium and plutonium, which they fabricated fuels for the Navy. And they also had smaller amounts of americium and thorium. Different health risks are associated with them. Uranium in particular, it can cause renal failure, diminish bone growth, and cause damage to your DNA. Plutonium can cause several forms of cancer, including lymphoma and leukemia. So the Parks Township site has seen many different owners over the course of several decades. This is a picture of the site during its production days. As you can see, the plants are located downslope from the whole area of the site, right next to the river. The first company to own it throughout the 60s was 𝐚𝐡𝐞𝐚𝐝. They're called the Nuclear Material and Equipment Corporation. All of their stock was bought out in 1967 by a company called Atlantic Richfield Company. but they didn't own the site for very long. They sold it to Babcock and Wilcox in 1971, and they continued production there until 1980. So along with the many different owners that the site has seen, it's also seen many different stages since the discontinuation of the nuclear production. In the bottom left photo, you can see an overhead view of the site. In the top left, you can see that the production buildings have been torn down. It kind of cuts off, but all of the buildings have been torn down. And in the middle right of the photo, there's a white building that had been built there by the Army Corps of Engineers in 2011 when they attempted an initial cleanup of this site. So the burial disposal of radioactive materials that they decided to use at this site was shallow land disposal. This is a technique where you put waste into a container and then seal it with a permeable membrane, impermeable membrane, so that stuff doesn't leak out, and then buried at a depth of 15 to 200 meters, typically. It's unclear what how they actually went about burying the materials, but a Wall Street Journal spokesperson has indicated that burial protocols have been violated, which can be very dangerous if they've improperly buried radioactive materials in the ground. And although we don't know how the materials were buried, we do know where a lot of the trenches are. 10, in fact, that the Army Corps of Engineers have located. And the white building that you saw earlier in the right-hand side of this photo, I don't know for sure, but I believe that's where they actually began extracting materials and started moving them to a safer location and burying them the proper way. So the reason this is a problem is because there are a number of residential areas in the local business park nearby. The business park is located on the left-hand side of your screen. Several hundred employees work there every single day. I should know because I was one of them. I worked in that building for 3 years. So I have a personal connection to this site. In addition to that, a few residential areas nearby, and the 𝐚𝐴𝐴𝐿𝐴 River, of course, is located downslope from this site. So in addition to that, the 𝐚𝐴𝐴𝐿𝐴 River flows northwest from this site, and located downstream are the two towns of Hyde Park and Leechburg. Leechburg being the bigger one with several more residential areas and businesses that are closer to the river. In addition to that, there is a syncline, the 𝐚𝐴𝐴𝐿𝐴 syncline, located above upslope from the site. And if you don't know what that is, when bedding is formed, it's horizontal, and tectonic events can fold those bedding planes to a hinge point, and from that are two limbs that come down from that, and they can be oriented in several different ways. So in conclusion, a phase 2 environmental assessment is definitely recommended for this site. Further testing of soil and of the water table and the 𝐚𝐴𝐴𝐿𝐴 River itself. Due to the length of time that the site was actively producing radioactive waste, the severity of the radioactive waste of the materials that were handled, the fact that they could have possibly violated burial protocols. There are several populated areas nearby, and the location of the 𝐷uquesne-Fairmount syncline. Thank you for listening. I'd like to give a thank you to Dr. Karen Rosapin for advising me on this project and helping me put it together. Thank you.
This brought us nicely back onto our timetable, so we have time for a couple questions before our coffee break.
This wasn't a question, more of a comment, but I live right by there.
Do you?
Basically, I've driven past it tons of times. I know people in the neighborhood right next to it. And I'm just glad that people are noticing this and noticing that it's a problem.
I'm probably 5 minutes from there.
Yeah, I'm pretty concerned about it could be affecting the river in any ways. I've heard of stories from people with family histories of cancer possibly linked to that. So I'm just glad that it's being
Yeah,
noticed.
both my uncle and grandfather used to work at the plant and they both had health issues
Yeah,
as they got older, cancer being one of them. So,
hopefully it gets taken care of properly. So.
yeah. Yes.
Did you by any chance look at any Atomic Energy Commission
I had
documentation
not.
like that? That would all be publicly available.
Okay. Yes.
Has there been a phase one done previously, and do you know if there's been any like exploratory download?
Yes, so I don't know about any of that, but I do know that the Army Corps of Engineers would have done a phase one at the site. I kind of did like a mock phase one as if the Army Corps of Engineers didn't do one. So I didn't look at any of their phase one data or anything like that. I just looked at it as it was a, preliminary site.
Do you know if the people living up against that do they have to disclose when they sell a property that they are living
I have no
right
idea.
up against a nuclear waste site?
I have absolutely no idea. Susie, I think you have one?
So you were talking about how they are safely buried as materials and they're extracting it. So once those materials are safely buried, are you allowed to build on top of that?
I'm not sure. I guess it would depend on what kind of business that you were going to put there, or if it was like a plant or something like that. I don't know that you would be able to put a residential area over top of it, especially directly over top of it, but I'm not entirely sure on that.
Thank you very much. I think we have coffee break materials, and I would like to encourage all of our seniors to get their posters out so that we can talk further, especially those who have already presented. If there are any further questions for them, that would be great. All right. Katie, do you want to leave the live stream going?
They just sent the I've actually been really interested.
Yeah.
Can you just add, we'll start again?
I was just thinking I should probably add that, shouldn't I? Yes, I should.
Because I'm just
I
leaving it
totally
streaming.
can. Yeah.
If you lose our link, because sometimes Zoom will time out.
Right, if nothing seems to be happening.
Yeah, we probably should put it on.
We will return or resume. How's that? We will resume talks at 10:30. Okay. There we go. And will it now show that? Okay, so Zoom. I know. Why is it not? Oh, because probably the meeting controls are. They're on the other screen.
Here.
But see, they're on that screen is the problem.
So is that to the right? Yeah, I got it.
Okay, good. Oh, aren't you smart? Done. Okay. Didn't bring my cheat sheet with me. Okay, Katie, do we have it set right like that? Katie, take a look. Does everything look okay on the Zoom? Okay. Yeah, just check, double check it.
Yeah, it's working.
Okay, great. All right. Well, welcome back from coffee break, everyone. Thank you very much. We'll start just a little bit early since everyone's sitting and ready. And so is our speaker, I think. Our next speaker, continuing with an environmental theme for our first few talks here, is Molly Rabon, and she'll be talking about her water budget study of Marsh Run Watershed, a small urbanized headwater stream. Molly.
Hi, everyone. I'm Molly. And like 𝐚𝐡𝐞𝐚 just said, I've been working for the past year to determine the water budget of Marsh Run Watershed. So Marsh Run is considered a headwater stream, meaning it is the furthest point from the network's endpoint and the smallest part of the flow network itself. Marsh Run is located in Indiana, PA, shown by this red star, and Indiana consists of 4 main watersheds: McCarthy, Stony, Whites, and Marsh Run on the right there. Understanding a water budget is important for assessing different impacts on a watershed, such as land change use, ecological impacts, environmental impacts, things like that. Understanding the water budget can help lead to better remediation techniques for flooding. And this image here on the right is actually from South 7th Street in Indiana, showing a little bit of flooding we got one day from a rain event. So a water budget is just accounting for all inputs and outputs of water through a watershed. Input through precipitation and groundwater, and output through evaporation, evapotranspiration, runoff, and also groundwater. Our goal is to determine the precipitation and runoff components using precipitation gauges and stream gauges. So first, looking at the data collection for precipitation. For this model, we assumed that rain fell equally over the entire watershed. So we used that whole area to get these measurements. We collected 64 rainfall events that ranged from 1/4 of an inch, less than 1/4 of an inch, to greater than 7 inches, where I think our largest rain event was about 7.7 inches. We collected this from 2018 and 2019 from daily data from the National Weather Service. We collected daily accumulation of rain through rain gauges that are placed throughout Marsh Run, which allow you to kind of see the episodic nature of these rain events. So the kind of start and stop of the rain. So on the left, you can see that episodic nature, and on the right, you can see in red the total or cumulative amount of rain that fell. In this case, it was a pretty small event, only about 0.16 inches. So next, looking at the runoff collection. Runoff can be determined through stream gauges placed throughout Marsh Run, where these stream gauges are placed in a PVC pipe with holes in it to allow water to freely flow around it, and then that's connected to a wire or a string connected to a tree or pole outside of the stream bed. These stream gauges measure temperature, conductivity, as well as atmospheric pressure plus the hydrostatic pressure to get the water levels. However, for this project, we did not need the atmospheric pressure. So once we compensated that data, we were able to create these hydrographs and we're able to calculate under the curve to get the total stream runoff volumes. So here you can see this is the stream at base flow. This is when the rain event would begin, and it shoots up within 15 to 20 minutes, but takes about longer than 12 hours to not even return back to its base flow. Our data collection also entailed of some field work in the stream. So here in this image, you can see we were surveying the stream. We went about 30 feet downstream and upstream to get the change in elevation and get the slope. And then on the right, you can see Susie and I, we draped a tape measure across the stream and measured every 5 centimeters to get that cross-sectional area at that point. Once we had that data, we were able to implement Manning's equation to determine the total discharge of the stream. So for Manning's equation, we needed a roughness coefficient, which is basically just a constant telling you what the material is at the stream bed. In this case, it was a pebbly bottom. You also need the cross-sectional area, which we measured in that picture on the previous slide, and that would be this kind of shaded blue area. We needed the hydraulic radius, which is highlighted in yellow, or the wetted perimeter of the stream, and as well as the slope, which we collected through surveying. Once we had all this data, we were able to implement the equation and calculate Manning's for 20 different water levels to kind of create a rating curve to see water levels versus discharge. So here in this animation, we just did these 20 levels. This is the bank full state. This is kind of where the water was initially. So discharge stage rating curves were calculated using that Manning's equation and the 20 different stages. We fit the rating curve with a polynomial fit that kind of better estimated the larger water level versus discharges, where the power curve in the blue didn't really, it kind of overestimated the larger events and kind of fit more of the less influential ones. So we took each individual event and determined their water budgets, and we resulted in about 50 to 97% of water or of rainfall not seen by the stream discharge. So with that high percentage, we kind of wanted to go into maybe why that is, if there was any correlation between wet or dry events. So a wet event would be where it had rained the day before, the ground's a little more saturated, the stream is not at base flow, and a dry event would be where we see the stream at base flow. So in this image here, this is base flow, this would be a dry event, and the next one would be a wet event. There's no clear correlation with events under 2 inches. However, once you get into kind of the higher 5, 6, 7 inch rain events, there's a steady decrease in the percent of rainfall not seen in the stream discharge. However, overall, we still are seeing large amounts of water unaccounted for by the stream discharge. With that large percentage, we wanted to kind of scale back and look at a monthly scale water budget, which we determined for the year of 2018 using an event versus base flow technique. So you can see in this time series here, we have discharge on the y-axis and time on the x. You can see base flow in orange of the stream and all of the event flow, which would be added from the rain event, in blue above it. We were able to stack the base flow plus the event flow and compare that to the total rain that fell. And every month we had data for, except January, resulted in, again, large volumes of rain that are not accounted for just by the stream discharge. In January, we assume this is opposite only because 6 inches of snow fell in December, but didn't melt until January. So again, the water budget here is large amounts of water are unaccounted for solely by the stream discharge. So our goal was to determine these precipitation and runoff components. We did that, we got these large percentages, and we wanted to kind of further continue and look into where this water could be going, where we could have made a mistake, things like that. So first, looking at the precipitation gauges, like I said in the beginning, for this model, we assumed rain fell equally over the entire watershed. However, we only assumed that because we really just use one reliable rain gauge in the watershed that matched up with our stream data. However, there are multiple rain gauges in Marsh Run, and they all report back different amounts of rainfall for each rain event. So for this, I think possibly dividing Marsh Run into its sub-watersheds, you're going to be able to kind of get that number down and maybe have a more accurate, not more accurate, but a better water budget for the smaller sub-watersheds. Also, with groundwater, a lot of our larger rainfall events reached that bank full state, overflowed the stream bed, and when that happens, we're going to lose a lot of that water to infiltration, the water table, things like that. where that water will infiltrate back in eventually, but not right away at all. And finally, we wanted to also look into the Indiana Borough wastewater treatment facility, where they see about 5 million gallons of water come through daily just from us flushing our toilets, water going down your sink, things like that. However, during these large rain events, they are seeing up to and over 30 million gallons of water coming through their system, where you're not supposed to see any increase in the wastewater plant from rain during these rain events. So this is most likely due to bad piping, infiltration, things like that. With this high percentage, I encourage future students to address these issues to determine a more complete water budget for Marsh Run, possibly doing some percolation tests to get infiltration rates of the soil, separating Marsh Run into its subwatersheds, like I just said, or even installing a couple wells to watch the water table around the stream. And I just wanted to thank Susie Adams and Connor Caston for all the help with field work, and my super awesome research advisor, Katie Farnsworth. And I'd be happy to answer any questions.
Questions for Laura? So the slide with the data, why do you not have data June, July, and August?
We didn't have reliable data for, we did not have reliable data for those months with the precipitation data and stream data. We just didn't have the stream data that matched up with it.
What do you think would be expected in those months from the trends that you're seeing?
From the trends I'm seeing, I'm assuming that the event versus base flow will probably be close to where it is in May or even lower, with kind of a high amount of rainfall again, not being accounted for by the stream discharge.
Do you have a sense for how thick you mentioned that the bottom of the stream is basically pebbly, it's got sediment, but bedrock is presumably not too far from the surface. Do you have a sense for how far it is down to bedrock, true bedrock?
For this project, we didn't look into that at all.
I mean, if you're thinking about the water budget and the water table on the floodplain,
Yeah.
that would be something.
Yeah, I think for future work, it would be good to look at where the water table is for sure. I think that's definitely getting affected.
Look at, I know you're using data from 2018, you all collected, but was 2018 kind of a typical year? Was it a rainier year, a drier year? Is it? Can you get an idea, a sense of, from one year's data? I guess, did you look at any other year's data to see how typical this data set was?
For the whole project, we used 2018 and 2019 data, and they were honestly pretty similar. There was really no outstanding changes between the 2 years. So I think 2018 was a pretty normal year for rainfall.
Did you do any wetland characterizations to see if the wetlands above or below the subwater were experiencing the inflow and outflows that the watershed was experiencing?
We did not look into any wetland information. All we kind of looked into was the backup in people's basements, overflowing the streams, things like that.
Thank you very much, Molly. All right.
Gavin, you're up next. Okay, so our next speaker is also going to be looking at the area around Indiana. Gavin Vashie did his research on microplastic contaminants in our freshwater systems. Gavin.
Right. Hello, so my name is Gavin, and yes, so how she was saying. So I was looking at microplastics in effluent that was being released into a local stream here. Make sure I'm a little bit out of the way. So microplastics are anything less than 5 millimeters in size. For this study, we used sieves. I'm limited down to 63 and 125 microns. And for scale there, that's about the size of a human hair to a grain of salt, roughly. And they're either to be designed that way through like certain products, or physical weathering has occurred to them. and like sediments in a stream, and then they get weathered down like sediments in a stream there, to where the breakdown of a plastic can be broken down to the size, if not designed. All right, so the microplastics are in everyday consumer products and industrial products. Primary microplastics on the left will be something such as like in your clothing for synthetic. And so what makes it a primary microplastic is that it's going to be on micron in size when it gets released. And on the secondary microplastics here, we can see, so that's going to be a breakdown of a larger piece of plastic, such as litter here. It can get into a water source or any other energy source where sun can either weather down onto it. And that could be a problem just because of our aquatic life here, can ingest that and then we can eat them and then consuming their energy along with any microplastics they come in contact with. All right, so there's 4 categories of microplastics, being your fibers, beads, fragments, and films. Your fibers here are going to be elongated strands. They come from synthetic clothing usually, and that's released during laundry. Your microbeads are more spherical in shape, and they're more in abrasive cleaners, such as like facial cleansers, toothpaste even. Your fragments down here are usually more rugged in shape, and they come from just fragmenting off of larger pieces of plastics. And films, lastly, are more like a film, like thinly layered type plastic particle. And they usually come from like grocery bags, food wrapping, and things like that. It's kind of thinly layered. Then we have our microplastics again on the top here and secondary microplastics on the bottom. So the purpose of this study is to bring numerical data along with awareness to this unthought of problem here. The hypothesis is that more students returning to the campus after the COVID-19 lockdown will bring more plastics with them. And just how you can think of, we expect, and I was expecting larger levels of microplastics just with a larger population, same way waste and sewage increases with a larger population. And just how I have laundry and groceries here, more people consuming products where there's plastic all around them, or just more people doing their laundry to this area. Okay, and then so like was said earlier, it's local here within Indiana, Pennsylvania. About 10 or 15 minutes away here, we have the Indiana Regional Wastewater Treatment Facility, to where it treats White's Township, IUP, and Indiana's wastewater. And so whenever the waste gets into the sewage plant there, it's separated, and then the effluent is released into Stony Run. And effluent is just water safe enough to be released into the environment after bringing the waste to the plant there. Right, so monthly samples were collected with a stainless steel sampler and an effluent hatch like this here. There's multiple ones over there, but this was the main one. And so we lowered the sampler down into it. We filled a glass jar, a liter size one, with the effluent. And the reason why we use your stainless steel, metals, glass, ceramic is because we're testing for plastics, so we kind of want to try to limit that. And once that is brought back to IUP, it was either collected by myself or a plants member. It was placed into a refrigerator to prevent future growth of any organics. So once we got back to the lab here, we poured the effluent jar into our sieve stack, and it was recollected with those beakers there for future sampling, just for like something as in like nanoplastics or other sizes of microplastics. Your nanoplastics are from 1 nanometer to 1,000, while your microplastics are 0.1 microns to 5 millimeters. So once everything is caught through the sieve for the month and size, we go over to the aluminum containers. We use that squeezable plastic bottle there with distilled water. And then over that, we just loosen the materials into that, leaving water, effluent, and organics. And then we add hydrogen peroxide to that, just to kind of kill and separate any organics that are still left in that sample. And then once that is done, we bring it over to a kiln to kind of speed up the evaporation rate there. All right, so once the liquid is fully evaporated, we bring the aluminum containers that were organized by size and date there over to a stereoscopic microscope to where we can kind of categorize and classify these plastics. And here we have a microbead with fragments that kind of curled up on the top right there, and then our two fragments of different colors there. And so with the year of sampling there, we found 83 microplastics. So that's from all classifications of microbead, film, fragment, and fibers there. So we can see in the fragment here, these like black specks there will be your organics. So it's more than just microplastics there. So here we have our graphs of the results here. We have it classified by classification of the microplastic along with the sizes. So the start here is the COVID pandemic, to where we have a little bit lower. The middle is going to be our summer break here, and then towards the end will be a full return of students coming back to the campus. And we can see an increase in fragments and fibers here, along with no giant size variation. And here is a pie chart that kind of depicts the fragments and fibers being the most dominant microplastics found within our study. The fibers and fragments are from the two different categories of primary and secondary, which I thought was interesting. We kind of see of both there, along with your films and microbeads as well on a lower scale. So the conclusion of the study was about 126 million microplastics passed through the effluent on a daily basis. And that was just based off extrapolating the 5 million gallons of water they go through the plant there on a daily basis. We did that by just scaling up practically from the 3.4 gallons that I tested and the microplastics that I found within that. All right, so microplastics are all around us in this modern era. It can be inhaled, ingested, or even absorbed through our skin. There's even new studies saying that it's found in our blood. That's causing numerous health effects such as cancer, DNA damage, and hormonal damage as well. That's mainly caused by the chemicals that are placed when they're manufacturing the plastics, such as BPAs, phthalates, EDCs. That's just the chemicals they put into the plastics when they're making them. And here we have another film there. It's a little arrow. And so this topic can be expanded upon in the future. More sampling to the effluent. It can be expanded to the local streams around the facility. And then even use the use of 𝐚𝐥𝐤 to kind of measure the area and total length of the microplastic particles. So that's kind of defined or further classify the plastics that we've found. And we can do that by like tracing it back a little bit further, saying like facial cleanser only uses a certain size bead. We can kind of see that's more likely to come from that. And then here I even have an image of like a waterfall here just behind the plant. And even this bottom left corner there, I think is a plastic bag. Just saw us skyrocket. I wasn't even looking for that. I'm just that it was present there as well. And here I'd like to thank my advisor, Dr. Kay Farnsworth, my peers and other professors here at IUP, along with the Indiana Regional Wastewater Treatment Facility for just letting me gain access to their facility. And thank you all for listening. If there's any questions, I could take them now.
Questions for Gavin?
Yes.
How do you think that the microplastics would act in the flow system compared to typical sediment, sand and clay?
Yeah, so depending on like their size, the smaller ones usually tend to fall to the bottom. And well, yeah, so it does vary. So this is like how sediments, the lighter ones float up in the higher column, while the lower is like sink and like kind of weather down along the bed as the plate get stuck or anything.
Obviously, they would have a much lower density than those sort of
For sure, yeah.
So, and then when you start getting into the smaller side, then you have to start thinking about the charges on the base material. So the fibers may act really weird compared to the.
For sure, like the yes.
Gavin, is there a protocol that's established for microplastics? Because it's really getting a lot of attention. I'm just curious about like an analytical protocol that you all followed, or is there any?
Yeah, so there's like it's kind of yeah, how you're saying that's really recent. So there is different developments of like procedures and everything like that. So I found different like case studies there. We try to model off of that and try to kind of semi-improve on their system with using sieves and everything. Yes.
You said you sieved water to extract the microplastics. Did you do any grain size distribution to get an idea of like average sizes?
No, we did.
Qualitatively or quantitatively?
No.
Do you think your information can be used in a way to retroact water treatment plants for microplastic filtration?
That's what I hope so, because the plant even asked for my data and then see my like presentation, everything like that. So I recommend maybe like a filter or something along the line, just to kind of limit that even further. That's probably that. Yeah.
All right, thanks again, guys. One more talk in our environmental part of our presentations today, and it's a more climate-focused one. So our next speaker will be 𝐤𝐿𝐻, and he'll be talking about temperature and rainfall patterns in Indiana, Pennsylvania, along with many other locations. Josh.
My name is 𝐤𝐿𝐻. I'm a senior here at IUP. My research was focusing on assessing changes in rainfall and temperature patterns to characterize regional variations in climate. So across the United States, we've found that we've seen observed climatic indicators, so large spatial differences. So specifically, we see up to 1.5 degrees Fahrenheit increase in temperature across the United States. That's darker red areas, and up to a 15% increase in precipitation. And this formed the basis for our research to focus on a more local and regional scale, but in Western Pennsylvania. And we see, on the map there, you can see it's lighter colors, mostly in Pennsylvania. So that indicates that there's less substantial change. We wanted to focus more on that area to see, what kind of changes we see around here. And that's based on data since 1991. So just a little bit of background. So there's many impacts associated with the changing climate. So one of the main impacts is on flood mitigation and planning. So that would have an effect on like splashy streams. So that image shows from 2017, a stream that came way over its banks in Indiana, PA. And so some other impacts would be on drainage network capacity, as well as energy cost estimation. So energy cost estimation deals with heating and cooling degree days, which I'll explain in a little bit. And other impacts would be on like urban influences, like the heat island effect. That has large effect on human health. And other things that would impact in a large way would be agriculture and water resources. And you could use these impacts to model future climate scenarios as well. So for our project, we downloaded 21 National Weather Service stations in the Appalachian Plateau region, shown in that, it's that box on that first picture there. So that's Western PA, Eastern Ohio, Northern West Virginia. And that area has a pretty consistent elevation. We didn't want to go any further east because that's where all the mountainous terrain would have an impact on the station and the data. And then that right image just shows a typical NOAA weather station where this type of land-based station data is collected. Okay, so this map is showing a map of all the stations that we used in our analysis, along with their period of record, which is indicated by the size of the circle, as well as their elevation in meters. And we see a pretty consistent spread between 200 to 400 meters across the viewing area, which is helpful in our analysis. And we see some stations that have a period of record over 100 years, which is pretty significant. And that's good for analyzing trends over time. And some of the stations we couldn't use, these are small red dots because they had limited data. And we had to focus on using stations that had a period of record of at least 30 years to find accurate trends over time. Because if you use shorter than that, it wouldn't be good trends. You wouldn't be able to get a good analysis. You wanted to look long term. So how we got the data was from the Climate Data Online service, which provides free access to to archive global historical weather information. And that's the top image where we got it from, and the bottom image just shows what it would look like when we downloaded it from that site. It was all daily summaries pretty much of the data. And that's where we got it from. Okay. So we used MATLAB to create monthly averages for each variable every year. That's after we had to clean the data in Excel, and then we had what came in thousands of rows, we had to clean it and manipulate it a little bit before we put it in the MATLAB. So we used daily values for each variable. Those included like daily precipitation, annual number of rain days per year, and then the maximum of the monthly temperature and the minimum, the highest it got and the lowest it got over a whole month. Those are some of the main variables that we used at the beginning. And that graph just shows an example of a time series analysis where we can look at trends over time. That's basically how MATLAB characterized the data. So based on the slope of the graph. So depending on how steep the slope is, it would indicate if there's a trend or not. Like that top image just shows it's pretty neutral, so we'd probably say there's no trend for that, but the bottom graph it would because it's pretty significant down. So we used Mann-Kendall non-parametric statistics tests to identify trends. And so non-parametric just means that it does not require any prior distributions in the data, so it's just pretty much random. And they analyze one time series of data at a time. That's what Mann-Kendall means. So we find, and it finds pretty large trends in the data for each variable of interest. And that graph on the right just shows an example of what it shows that once again, the trends over time. Just an example of the statistic tests and how it would calculate it based on the slope. So next is the results. So this is the first result we found was that rainfall totals are increasing on an annual basis. We found the positive trend, which is those green circles at 8 stations across the viewing area. And they're pretty much focused to the east and north of Pittsburgh. So we found that pretty interesting that they're kind of focused more out east and north, but that's the first. So the next result was that the total number of rain days per year is increasing. And that's based on a 3-month period from June, July, and August. We had a group of data together. We had the group of those 3 months and then average it. But that was in MATLAB as well. And we found a positive trend at over half of the stations. And yeah, so that's pretty significant that we found that rain days are increased. That's just the number of days per how many days it's raining, like with measurable precipitation over the summer months. So next is cooling degree days. And let me explain what that is. Those are used for estimating summer energy costs. So we found that only 4 stations had a positive trend. But at those stations, that would mean that more days we're using air conditioning is necessary to maintain a stable indoor temperature during the summer. It's mainly just for energy costs. So an example calculation of that would be you add the high temperature and the low temperature together and divide by 2. And you get 73. That would be an example. And it's use a base temperature, anything you want, any base temperature. If it's above the base temperature, it'd be a cooling degree day. And if it's below, it'd be a heating degree day, which I'm going to get to next. So heating degree days are used for estimating winter heating costs. So we found a negative trend at 9 stations, I believe. And so the calculation would be the same. You add the high and the low temperature together and divide by 2. And if it's below the base temperature, it would be a heating degree day. So that basically means, we found that at 9 stations is a negative trend. So that means that winter temperatures are moderating over time. And for summer, that would mean that since we only found 3 stations with a positive trend for cooling degree days, that would mean that it's moderating in the summer too for high temperatures. So the next result is that summer low temperatures are increasing. That's based on all those green positive trends at well over half the stations. So it's warming up at nighttime. I think that has to do with like an increase in the dew point temperature, more humidity, and also maybe due to the heat island effect around the urban areas since they're growing in population. And another trend that we found
related to this that I didn't have a graph on here for is that high temperatures. We found no trends at all for any of those. So that means that the high temperatures in the summer, they're not increasing at all. It's just at night, so it's just moderation a little bit. Okay, so this is another analysis we did, was a stream flow analysis. We did this to do a comparison with the precipitation. And to do this, we downloaded from the USGS peak stream flow monthly mean discharge for 12 stations around the viewing area. We just wanted to compare it with the precipitation to see, since we saw increases in precipitation, we wanted to see if it was a correlation with the stream discharge rates too. We found a positive trend at all those stations that are labeled in blue there. And 3 of them we couldn't use because they were regulated. So all these are pretty small streams. We couldn't use any larger rivers because there's dams and regulations that didn't mess with the discharge information. So we found some, and we did find some correlation with the rainfall because we see those positive trends at all those stations. And those numbers just mean it's a slope value. It's like the same calculation that we did for the precipitation. It's pretty similar. So in conclusion, these abnormalities are definitely indicative of a changing climate. Just in summary, we found that rising summer low temperatures over time and the summer high temperatures are not increasing over time. And that's because we found that the really cooling degree days are only 4 stations had a positive trend. So that's not very significant. And another analysis we didn't say that they were either. And we found that winter temperatures are moderating over time because of the heating degree days. And some of the station, and for especially the overnight lows, we've seen that they're accelerating during the past 20 years, more so than over like the last 50 or 100. And we see changes in seasonal energy usage due to the changes in heating and cooling degree days. And then finally, we found an increase in a number of days of rainfall in the summer. So this is just my works cited slide, and I want to thank my research advisor, Dr. Katie Farnsworth, for all her help during this project. And I'll take any questions that you might have.
Questions for Josh?
Yeah.
How would you modify your model to account for like the Appalachian Valley and Ridge Mountains and areas that aren't like the plateau?
We would have to get some more stations from out east and try to compare it with the stations we found in the plateau region, see what differences we find, and then do a comparison. And I think that would help. Questions? Yeah.
When you looked at some of the sites I'm kind of partly familiar with have really long time periods.
Right.
Where the data is available. Did you look at see any changes when they moved the specific site? For example, the one in Morgantown has been in 3 different locations over that time period. One of which was kind of downtown. The next one was in an intermediate spot, and the next one was out at the airport.
Yeah.
So that would change, the readings dramatically.
Yeah, it does. It has a big influence. We had to win out some of the data that wasn't accurate. We didn't think it was right. Some of the stations we had to re-download and get new information for some of them. So that's what we had to do. Yeah.
Did you account for any elevation changes between the data stations? I know you said they're about equal, but did you see any spikes or any decreases based on the digital elevation model?
We did not, no. We didn't really look at that too much, but yeah.
Should we look into doing some cloud seeding over the state of Indiana and Ohio so we have less rain in the summer?
I don't think so.
We should look into that. Thanks.
Careful with that.
Okay.
Anything else?
So, switching gears now from present climates to past climates. Our next speaker is going to be telling us about his research. If I can find it, there we go. Which used diatoms, tiny little critters, to model Antarctic sea ice during the Pleistocene. Christian.
So we're gonna take you back in time a little bit here. So my research was to use diatoms to model Antarctic sea ice during the mid-Pleistocene. Specifically, I looked at the age range from 725,000 to 900,000 years ago. So first of all, just what is the point of everything, and some background information to help you guys get up to speed. The first thing we need to talk about is the LR04 stack, which was put together by Lorraine Lysecki and Maureen Ramo in 2004, 2005. It measures the amount of oxygen 18 in the ocean, which is an isotope of oxygen. So oxygen 16 is lighter and it gets evaporated faster. And so as the amount of oxygen 18 in the ocean increases, that means that the lighter isotope had been evaporated and sequestered away in glaciers somewhere in the world. And so this is kind of our roadmap for how much ice volume there was on the planet as a whole, all through history. So that's going to be largely important to my research. Basically, bigger number means bigger ice volume, lower number means lower ice volume. So the peaks are your glacial periods and the valleys are your interglacial periods. So this record does go back way farther than the window of time that I'm dealing with. It goes back about 4 million years. But I specifically narrowed in on this window because about 900,000 years ago, the cycle at which our ice ages occur changed pacing. So before about 900,000 years ago, the ice ages were not as severe as they are now, but they happen much more frequently, about every 41,000 years. The cycle we're in now happens about every 100,000 years, and they're much bigger swings than they were in the past. And we're not really sure why that change happened. We're not even really 100% sure what's driving the 100,000 year periodicity. So that was kind of the goal of the study, was to narrow in on that window and see if we can add anything to the knowledge base of what was going on around that time in Antarctica. So diatoms are little algae that leave behind microscopic seashell fossils. Some of them are kind of football shaped. You got �𝐥𝐤 here is football shaped. Some of them are nice and round. Some of them are long and spindly. But each one of them can tell you a different story about what was going on in the environment when they were alive, based on how many of them there are. So more specifically, certain one of them really love sea ice. So these 5 fine gentlemen here live near sea ice. And so as their volumes increase, you can say that sea ice in that area also increased. Other diatoms can give you other climate information. So these guys, similar to sea ice, these live right on the edge of the ice front. And then the one over here is an insolation indicator. So it can tell you how much solar energy was reaching the planet during that time. So as for how we went about this, it all started with the International Ocean Discovery Program, digging up mud out on the Scotia Sea right off of the Antarctic Peninsula. I specifically dealt with Expedition 382 and site number 1538, which again is right off that Antarctic Peninsula. So shout out to them for going up and digging up the mud so that I didn't have to. It was very helpful to me personally. So this is what they look like when we get them at the lab. They're just little Ziploc bags of sediment, basically little packets of mud. So I extracted about 0.025 grams of sediment from each one, crushed it up and treated it with hydrogen peroxide and hydrochloric acid. That just dissolves away any mud or carbonates or anything else that might be in there other than the shells. Then it was allowed to settle through 2 liters of water and air dry onto slides, after which it was viewed through 𝐼𝐺 microscope. And I mean, this is kind of what I spent all my days looking at, just jumbles of broken up microscopic seashells. They all look very similar. And then the diatoms were identified and cataloged on a species level, put into a big spreadsheet that did most of the heavy lifting for me, honestly, on the math side of it. The species or the samples were then linked to depths, thanks to the International Ocean Discovery Program's core data lookup table, which is just freely available online. The depths of my site were correlated to the depths of the site next door, 1538, or the Doves 1537, which is the Dove stack. And then those depths were translated into ages using magnetostratigraphy. So as for what we actually found, again, the LR4 stack, this is going to be the roadmap that I'm going to compare all of my other data to make sure everything matches up with what we were expecting the planet as a whole to be doing around that time. So the first one is our absolute diatom abundance. I'd also like to take a minute to point out the dashed line here. There is about a 25,000 year gap in our record. So for one reason or another, the IODP wasn't able to recover core samples across that interval. So this is not just a flat linear trend. There's data there that we just didn't have anything to analyze. So we would expect peaks there typically. So yeah, the absolute diatom abundance is the amount of diatoms per gram of sediment. We were able to calculate that by keeping track of what the mass of the sample I was analyzing was and comparing that with how many fields of view, what the area of each field of view in the microscope is, and just calculating out what the total density of diatoms per gram would be. And so the sea ice indicators show pretty good agreement with the LR4 stack with a little bit of lag. So disregarding our missing data here, we've got a peak showing an ice age, and then that's followed by a nice spike in the sea ice indicators. And again, another glacial period followed by another spike in sea ice population. Sea ice edge indicators do largely the same thing. You've got an ice age followed by a spike in population on both of those. And then the weirder one, the insolation indicator, doesn't show very much correlation with the ice volume, which means that the increase in ice volume isn't necessarily driven by just solar energy. There are other factors at play in the climate that are driving these kind of things. So kind of top line results, as time goes closer to the present, these kind of sweep upward. And so even during the interglacial periods, the sea ice is able to maintain a slightly higher mass as we get closer to the present day. So when the planet was warmer, not as much of the ice was being melted away as was in the past. I'd like to thank Dr. Warnock for being my advisor and walking me through how to identify all these very similar looking guys. Dr. Farnsworth and Dr. 𝐕𝐶𝐿 for running 470 and 480 over the past year. The IODP crew for digging up the mud so that I don't have to, and for IUP as a whole. These are my citations, and if anyone has any questions, be happy to answer.
Questions?
Yes.
Go ahead, Susie.
What's your favorite diatom?
I can show it to you. This guy here, 𝐿𝐥𝐢𝐜, he looks like a hat, and I think he's cool. I also like Stellarema because they've got a little like ninja star in the center of them. They're real domed out, so it's hard to get a picture of all of it at once, but they're real easy to find.
That was my question.
Okay.
I'm just kidding. Okay, so you're looking at correlation between sea ice and number of these different species of diatoms. If my I'm not a diatom expert, I should very well know, but if I remember correctly, the nutrients within water, currents, things like that are going to affect those species as well.
Right.
Are you aware of any, like you're looking over a rather large time frame? Were there any significant changes or anything else that we should be considering that could have impacted?
So the shift to the westerly wind belt occurred around this time, and that's what was driving, or at least that's the theory for what was driving most of the Antarctic ice growth. And so that would have been kind of a secondary factor for what would have caused some of these populations to grow. But otherwise, yeah, this is the planet, the continents rather were largely where they are today. So the currents and ocean things would have been about the same. Yeah.
I just have a comment from YouTube, so everyone else has gotten claps and thumbs up. You got a clap and a penguin.
Sweet. Love that.
Just wanted to pass along that message from my.
Okay. All right.
All right. Geoscience Day, Adams.
I'm pretty dangerous. I'm happy when I'm sitting here.
To look at this and make sure I'm on the right one.
Scroll down to
Let's make it big.
because it was some of the sides are messed up. Scroll because it was down further. Okay, let's go.
Okay, all right, good. Just making sure because I know we had a couple versions. All righty. So our final speaker of the morning, there we go. I was going to say, I hope it comes up okay. Is Susie Adams, and she's going to be presenting research she's been doing for several years now in Taiwan on brittle deformation and fault analysis. Susie.
Thank you. Hi, everyone. My name is Susie Adams, and for the last 2 years, I have been working with Dr. Jonathan Lewis, constraining brittle deformation in Taiwan's eastern central range. Just a little quick background about Taiwan. So Taiwan is an island off the coast of China. So about 5 million years ago, the Luzon volcanic arc, which is down here, and Eurasia's passive margin, which is up here, collided, initiating high exhumation or uplift on the order of 5 to 8 millimeters per year, in the eastern central range. So I know 5 to 8 millimeters per year may not seem like a whole lot, but geologically speaking, the Earth is 4.5 billion years old. So over a period of 1 million years, this eastern central range has the potential to exhume or a rapid uplift 5 to 8 kilometers. So previous researchers have tried to understand this high exhumation rate by creating 2D and 3D models, but because of how complex the tectonics are in Taiwan, they aren't fully understood. So here's just 2 competing models that try to explain what's going on in Taiwan. Previous research has showed that Taiwan has a consistent northeast-southwest extension, and both of these models are showing that. So in first model is showing that Taiwan's eastern central range is extending to the northeast, and then in figure B, we see that it's showing that the east central range is extruding to the southwest. So our goal for this project is to provide these constraints for future 2D and 3D modeling by documenting the geometry and kinematics of the plastic to brittle transition of Taiwan's metamorphic core. So my research specifically focuses on the most southern part of Taiwan. So along the watersheds of the 𝐿𝐥𝐤 and 𝐿𝐴𝐼 rivers, as well as the Southern Cross Island Highway, which is the highway that connects the East Taiwan with West Taiwan, and as well as the Dawlun and Shinwulu watersheds. So like I said before, I focus mainly on brittle deformation. So I work mostly with joints, faults, and earthquakes. So just to explain the plastic to brittle transition a little bit, starting with plastic deformation because it's the oldest. So back before the collision, these rocks were near the mantle, and after the collision happened, they were able to be exhumed. And when that happened, they were exposed to deformation events that caused the rock to look like this. But we mainly focus on the last deformation event, which we refer to as S3, because it does cross-cut the other deformation event and the original bedding, which we refer to as S2 and S0 and S1. So as we're moving through the plastic to brittle transition, this picture is taking along the 𝐿𝐴𝐼 River, which is more the northern of the southern watersheds I was looking at. So what we're trying to say is that veins, which as you can see is this white line kind of moving throughout the image there. What veins are just joints. So what joints are when a rock cracks open, there's no displacement. It just kind of pops open. So, and sometimes minerals such as quartz and calcite can go in there and precipitate inside and close up and create a vein. But in here, we're saying that veins are recording the transition between the plastic and brittle regimes, because you can see right here with this yellow arrow, that is pointing to S3, and this red arrow is pointing to the vein. It's showing that this vein is the S3 is being cross-cut by this vein, and then down here you can see S3 cross-cut. Well, yeah, S3 cross-cutting this vein. So we think that this mutual cross-cutting relationship between S3 and veins or the transition from plastic to brittle. So not only can veins joints form veins, they can also evolve into strike slip and normal faults. So both of these images are taken along the 𝐿𝐷𝐿 River. So as you can see in this figure or this image on the left, that these joint sets are organized and evolving into a nascent normal fault. You can see this arrow here, and as well as over here, you can see the organized joint sets kind of evolving into a strike slip fault. And when I plotted both of these, all this data into a stereo net, we both see with these results, we see that these steeply dipping planes are showing that it is extending to the southwest. So, moving through the plastic to brittle deformation or plastic to brittle transition faults or brittle deformation. So it's the final stage of deformation. So this is along the Southern Cross Island Highway, and it's just showing an example of a fault. So here would be the striation showing which direction it's going. In this case, it would be a normal fault. So before I go into some of my results, I want to explain what a fault plane solution is, so you guys can understand what you're looking at before you look at the results. So starting with a reverse fault, so think of the pressures coming in from the white side. So along this side and this side, the pressures are coming in. So since the pressure is going east and west, it has to come out somewhere. So it's going to be extreme to the north and south. So think of a reverse fault, it's pushing it up. So this is that middle part is pushing up. And then for normal faults, the stresses will be coming in from north and south, which would be causing the east and west to go out, hence a normal fault, which would be hanging well down. And then strike slip, it would be this, for instance, would be a left lateral strike slip fault, because this right here would be the fault plane, and it would be moving this way. So originally this would be back here, so it would just be sliding to the left. And of course, what we're mostly going to see is a lot of fault plane solutions that look like this. So oblique normal faulting, which is a combination of normal and strike slip faults. So some of the results I saw along the 𝐚𝐥𝐤 River, which we did not have a lot of data from, but the little data that we did have did show that some oblique normal faulting, with southwest extension, as we saw it before, which is what we expected to see. And moving down a little further south, we have the data collected from the Southern Cross Island Highway and the Darwin River. We did have a lot more data collected from these two these two places. So we have what shows evidence of normal faulting occurring in along these two watersheds. So what I decided to do was compare my my fault models with my earthquake models, see what type of information that I could get and compare the two. So what I did was I plotted my earthquakes in QGIS by magnitude, and then plotted each fault plane solution by 1/10 of the degree of latitude. So starting at top would be like 23.1, 2, 3, 4. So as you notice, as we're more up toward the top here, we see more strike slip motion versus toward the bottom. Now we're thinking we're thinking this is happening because of Taiwan's complex tectonics. So not only is the Luzon volcanic arc colliding with the Eurasia's passive margin, but the Philippine sea plate is also moving obliquely northwest at about 80 to 90 millimeters per year, which we think is caused toward like central eastern Taiwan. So we think that that motion is causing some of the strike slip motion in the more northern two fault plane solutions. See, as we move away from that, we get more oblique normal faulting and normal faulting, which is what we expected to see. So I also compared them east to west as well as north to south. But because this is both these data sets are coupled with strike slip data, they both are showing oblique normal faulting. But overall, our results did show consistent northeast southwest extension, which was consistent with previous results. So I would like to thank the NSF for funding our project for us to be able to travel to Taiwan and collect their data. as well as Team Tecto, especially Lindsay Alman of West Virginia University and Lauren Donati of University of Delaware. And I would like to especially thank Dr. John Lewis for being the best advisor and mentor I could ask for over the past few years. Any questions?
There are a lot of lithological variability and would that affect the data in any meaningful way?
So lithology in Taiwan is mostly like a quartz mica schist. I'm not sure if that would affect anything. I mean, it's a very high metamorphosis rock. So it's a very, very strong rock. Any other questions?
Okay, John, go ahead.
What would you, what's next? Like, what do you want to leave for the next, like, what's the next step? What do we need to do next?
I would say next would be to write a proposal, a paper of all of our results and publish it would be the next steps. Any questions?
I'd like to thank everyone who joined us today to celebrate our student research. As you can see, we're very proud of everything they've accomplished over their years here. Dr. Deardorff, do you want to mention any of the other events that are happening both today and then around graduation before we break up?
Sure. Okay, so faculty, please don't forget that we are meeting to observe the 470 students, their presentations. That's 2 o'clock. I think line 06 for that.
Yes.
Yeah, line 06 for that. Don't forget that, and then immediately following the faculty meeting after that. In addition, we are having an in-person department graduation ceremony that's going to be on graduation day. Is that the 7th? May 7th, Saturday, May 7th. It's at 11:30 in Jane Leonard Hall, B11, if memory serves. So bring your friends and family that are graduating. Please come join us.
Okay, thank you very much. All right, and thanks again to all of you. Go out and enjoy the wonderful weather, and we'll hopefully see you at one of the other events today.